Now that last question should have felt pretty similar to what we did a lot in other units. So we'll look at something just a little bit tougher. So sketch the function y equals 4x minus 5 over x minus 2. Identify any asymptotes and intercepts. So we got a hint though. Rewrite the equation into the form y equals a over x minus h plus k. Oh yeah, our last equation actually already gave it to us in this form. This one we need to turn into, and it's something that's not intuitive. So the first thing I'm going to do is I'm going to try to make it so I can cancel out an x minus 2 on one of these terms. Now because this 4x already has an x and our denominator has an x, I'm going to deal with that one. So the question is, if I put x minus 2 here, I would need to get it so that it's like x minus 2 here as well. So 4 times something, or so 4 times 2, I guess, would be what it would be. 4 times 2 is going to get me the number that has to go here so that when I factor out the 4, I would actually get two things I can factor. Meaning if I put a minus 8 here, then it becomes, I can factor out a 4, and then I can cancel out this x minus 2, and I'm left with 4, which seems great. Problem is we have this minus 5 here though. So with how we deal with that part is, I'm going to just extend this, and I'm not allowed to just like, oh, I'm going to subtract 8. I can't do that. However, if I subtract 8, but at the same time say, hey, you know what, I'm also going to add 8. Well, I'm allowed to do that. That's okay. So then I go, because these are just 0 together, and then 8 minus 5, well, that's 3, positive 3. Now at this point, you're not allowed to cancel here because this 3 can't cancel with x minus 2. So you are actually allowed to split this up into two separate fractions then before we even cancel this out. It would be like 4 times x minus 2 plus 3, and they'd both be over x minus 2. And this is just kind of undoing some addition here. Now I can actually cancel out these x minus 2's, and I'm left with, and I'll rearrange this so this is first 3 over x minus 2, and then plus our 4. Alright, now we can actually graph it after all of that. So again, I like sketching the original first, so that's 1 over x, so we got 1 over 1. This is going to get very repetitive very, very quickly, so I'm just going to quickly sketch it for you. I do highly suggest you do this each time. Okay, so we've got our key points there, and I'll just again label, hey, that's y equals 1 over x. Okay, now let's take a look at our transformations that are occurring here. So we've got an a value of 3, so we're going to say we've got a vertical stretch by a factor of 3. We've got a minus 2 here, but that's only a 2, so that's going to be 2 right. And then we got this plus 4 here, so that's going to be 4 up. So it's important we do that vertical stretch of 3 first, then up 4, and then we can do that 2 right. Okay, so let's go and look at our graph then. I'll do the asymptotes first. I think it's helpful to see where those end up when we're sketching it. So if I'm going to go up 4 with my asymptote, so we're going to end up here at y equals 4. And then I'm going to go 2 to the right with my vertical asymptote. Okay, so that's going to happen at x equals 2. And now I can start just moving the individual points. So 1 comma 1, so I'll go times the height by 3, so I get to 3, then move up 4, so I get to 7, and then 2 right. So 1, 2. And do the same thing again. We'll pick this 0.5 this time, so times 3 is 1.5, and then move 4 up, so we get to 5.5, and then move over 2. And so you can see I'm going to get a graph that's going to approach the asymptote, but not quite hit it, and going the other way, so I'll take this 2, so times 3 is 6, and then move it up 4, so we get all the way to 10, so it's getting big very, very quickly, and then move it over 2. I think those asymptotes help to remind you that you do need to move it over, otherwise it wouldn't make very much sense. And then on the negative portion of our 1 over x, so same thing, so negative 1 times 3 is negative 3, then move it up 4, and then move it over 2 right. And we'll pick 2 more points. So we'll do this 0.5. So you get negative 1.5, moving it up 3. So we go 1, 2, 3, and then 2 right. So 1, 2. And then we'll do 2. So negative 2 times 3 is negative 6. And then up 4. So you get to negative 2. And then 2 right. And again, our graph is going to look... something looks not quite right with this one. So let's just double check that one. So you get negative 1.5. And then you're going to go up 4. So 1, 2, 3, 4. Ah, yeah, there we go. So let's just be a little bit higher. Okay, so now our graph is going to look good. Or well, as good as I'm going to make it look. Now we should have the intercepts as well. So we should have a y-intercept and an x-intercept. So our x-intercept is going to occur when y is 0. And I'm actually going to substitute it back into this one because when I go and solve for x, I'm going to multiply both sides by x minus 2. So actually that gets rid of this denominator right away. So I'm just left with 4x minus 5. So it's 5 over 4x. Divide each side by 4. And that's a lot easier. So we get 1.25, which is pretty similar to what I should have if this was a nice curved line. Yours, of course, will be. So we're going to do 1.25, comma 0. And then for our y-intercept, and that's going to be x is 0. It doesn't really matter which one I pick here then. I'll just, again, use the one that I haven't done anything to just in case I made a mistake. It might catch something, possibly. 0 minus 2. So I get y equals negative 5 over negative 2. And so that turns into positive 2.5. Again, makes sense. It's kind of a nice little double check as well. And I guess this one possibly was supposed to be there. I don't really want to go back and look, but we got 0, 2.5. So now we have all the important points. And our graph looks, well, kind of all right. So basically an identical question, just changed a little bit, just get some more practice at actually getting rid of its denominator as part of both terms, or canceling out one of the denominators. So here we have 2x plus 2 over x minus 4. We need to make it so that we can cancel out an x minus 4. So again, our thinking is 2x and then x minus 4. So we have to wonder, well, what could I put here so that I could cancel out an x minus 4 when I factor something out? Well, 2 times negative 4 is negative 8. So then I'm left with 2 times x minus 4, which is exactly what we want. Now the other part of my equation, though, still exists. We have that plus 2 over here, and we're not allowed to just subtract 8 whenever we want. So if I subtract 8, I also have to add 8, so that these equal 0. And then 8 plus 2 is 10. And now I can break apart this into its 2 parts. So I'm going to be left with 2, and then I've got that 10 over x minus 4. And so now you can actually see what the transformations are. And all of this is y equals. So it looks like we have a vertical stretch of 10, or by a factor of 10, and it's going 2 up. And then as far as right to left, it looks like we're going 4 right. So I'm going to do the asymptotes first. It looks like our horizontal asymptote goes 2 up. Make sure you label that. So that's going to occur at y equals 2. And then our vertical asymptote is going 4 right. Of course, you're going to use a ruler. So we get x equals 4. And I'm going to just quickly sketch out what y equals 1 over x is. You should be able to do this faster and faster each time. Doesn't take very long. Just to plot out a couple important points. Now, when we've got such a big vertical stretch, lots of these points aren't going to be of much use. And now we can start transforming each individual point. So I'll start with 1, 1, so times 10, and then 2 up yet, and then 4 right. So 1, 2, 3, 4. It's going to be somewhere way, way up here. And this is going to it's getting big real fast, so that's going to be my only point I'm going to be going up. So let's try to get another point that's going down to the right. So let's look at 0.5. So that gets me to 5 times by 10, and then 2 up. So then 4 to the right. 1, 2, 3, 4. I think I'm going to be able to get this other one in here as well. So 0.25 times 10 is 2.5, and then 2 up. So 1, 2, and then 4 to the right. So 1, 2, 3, 4. You can see it's going to get pretty slow this way. So something maybe like that, but it's very, very steep as we're going to the left. And then for our negative portion, we're going to be crossing the x and y axis here. So maybe we'll do this first to kind of give us some nice guidelines. So we're going to let, so we'll do our x-intercepts first. So we're going to let y equals 0. Again, I'll use this original. It's kind of nice that it cancels out the denominator for us. So we'll multiply both sides by x minus 4. So you're left with 0 equals 2x plus 2. And then I'll subtract 2. And then I'll divide both sides by 2. So you get x equals negative 1. So then my point becomes negative 1 comma 0. So we can plot that. Negative 1 comma 0. And for my y-intercept, we're going to let y equal, sorry, this is y-intercept. Y-int. And that's where we're going to let x equal 0. I'll use my original. Again, I think just it's kind of safer maybe. If I made a mistake somewhere, I'll catch it, hopefully. Plus 2, and then 0 minus 4. So we're left with 2 over negative 4, or negative 1/2. So then I should have a point at 0 comma negative 1/2. So 0 comma negative 1, which makes sense based on this graph. Is probably going to look something a little like that. So I'll just label that 0 comma negative 1/2. You can barely read that. And this one's going to be negative 1 comma 0. Okay, now we're going to move some points. So our negative 1 times 10 is negative 10. And then we're going to move up 2. And then 4 to the right. So 1, 2, 3, 4. And it's getting pretty close. I don't know if we can get it much more. No, there's no way, because negative 2 times 10 is negative 20. So that's going to be the end of that graph. So this is going to connect. It's going to get very, very steep. And then going to the left, we've already got 2 nice points. It'd be nice to have one more out here maybe. So we'll do our negative 2. Negative 2.5 is negative, because we're timesing that by 10. Then we're going to move up 2, so we get to negative 0.5. And then we're going to move 4 to the right. So 1, 2, 3, 4. Oh, and that's the point we already have. So we'll kind of just sketch the rest of that then. And there we go. So now we have graphed that reciprocal function.